let's go ahead and run this and make sure I know how to program and this all just works. How awesome is that? All right, so a bunch of you like my previous video where we made a progress bar in Bash. I got a ton of positive feedback on it, and a lot of the comments were like, hey, this is awesome, but why don't you do this? Why don't you do that? There are a couple different ways I could see it making this better. Dave, how come you don't do this? Guess what? That's what this video is for. Today we're gonna nerd out even more. Take a look, I got the glasses on today. That's how you know this is serious. We're gonna go into a deep dive. We are going to make that progress bar from the first video even cooler. If you haven't seen that first video, don't worry, I'll catch you up to speed on what we're doing. Yeah, let's jump into it. So here's what we have from the first video. Look how cool that is. Basically what this does is it loops over files on my file system and processes them. It doesn't do anything. The main goal of this was just to make a progress bar that could handle batches of files and prints to your terminal. That's pretty cool. It tells you how many files it's processing. It tells you the percentage. It prints 100% when it's done. That's awesome. Let's take a look at the code just to remind ourselves of what's going on here. So we have a batch size variable at the top. This is how many files we're going to process at once. We could change this to 5. Let's rerun that script. And now we'll go 5 times faster. Look at that. We're processing them in chunks of 5. Hey, that's awesome. We have a progress bar function here. To learn how we implement this, go check out that first video. I'm not going to spend too much time going over this. And then we have our process files function. This is where we actually process the file. As you can see, we don't do anything to process the file. We just fork out to sleep with a fractional value. So only certain versions of sleep will support this, but most versions of sleep seem to support this. We find all of the files that have cache in their name or that end in cache. So in our files directory, you can see there's going to be a lot here. There's a lot of files that end in the name cache. I think I just have exactly 1,000. Nothing special, nothing fancy, no trickery going on here. Just 1,000 different files that this thing loops over. So it finds all the files that ends in cache, loops over them, prints the progress bar for the current batch, and then processes the current batch. That's all it does. So we're going to extend this and we're going to make it a little bit fancier by addressing some of the comments you all had. Before I do that though, I want to clean this script up a little bit because we're going to spend a lot of time working in this script. Let's go ahead and make it a little bit nicer. How do we do that? Well, look at all our logic here. Let's go ahead and put that in a main method so we can just kind of clean up the control flow here. So now we have our main method. We have to go ahead and call the main method down here. So if we do this, this just calls main with whatever arguments we gave the program. We're not giving it arguments yet, but we'll get to that. So in our main method, we'll turn on these shell options. We'll echo finding files. And then we have these 2 variables. Let's go ahead and declare these local so they don't bleed into any sort of global scope here. And then, yeah, I think the only thing we need to make local here now is I. Let's not forget to do that because things can get really weird and you forget to do that. So all we've done is move everything into a main method and then call the main method below. Let's go ahead and just rerun it for our own sanity. And hey, that's awesome. That works. So what's the first thing we can do here? What was the biggest comment I got from people? I'll tell you, it's right here where we print the progress bar line. Notice we put a carriage return here at the end. What that means is we print the progress bar, we move the cursor all the way to the left so it can be overridden. And what that looks like in practice is, look at this. See that cursor? It's on the left-hand side. It's kind of ugly, right? So I got a bunch of comments from people saying, hey, Dave, why don't you just put the \r here, get rid of it at the end. So put it at the beginning of the line instead of the end of the line, and let's see what that looks like. Hey, look, now the cursor's all the way to the right. That's way nicer. I like that way nicer. Just a super simple, small fix. Technically speaking, a couple of other people said, hey, you could hide the cursor. If we do that, then we have to start handling things on cleanup. We'll get back to that. But for now, let's put the cursor on the right. That looks nice. If the progress bar is small or big, whatever, it's all the way over there. We don't have to worry about it. And then if the process were to like crash or something or die in the middle of it, we wouldn't have to worry because the cursor is here. So the prompt will show up on the new line. That's really awesome. That's a really cool, simple, quick fix for this. All right, another thing we can do to clean this up is instead of taking batch size as this global variable that's defined in the script, we can take it in the main function here as an option. So we could start reading options this way. We could say while getops, let's do B for batch size, colon meaning it takes a value, and then the variable we want to call us will be opt do. If you've never seen the syntax before, don't worry, I'll explain it. We're going to do a case statement over whatever option we just received. So that was the variable opt we defined here. Case opt in B, meaning the user gave us a B option. We're going to set batch size equal to whatever they gave us, which is all caps opt arg. That's built into Bash. This is how you do argument parsing in Bash. The double semicolon means we're done with this block of the case statement. If we get here, then we had a bad option. Let's go ahead and call fatal with bad option. GetOps will already handle emitting an error to standard error, so we'll know which error, which character was given that we don't support, but that's not a problem. So let's go ahead and do that. Call eStack here. There's a couple things we need to do before we move on. First of all, like an LLM, I just hallucinated this function here. We don't have a fatal function, so let's go ahead and make a fatal function. Fatal function will be super simple. We'll take the message the user give us as an argument. We'll print fatal. We'll print whatever they give us as arguments, and we'll write it to standard error, and then we will exit with the error code 1. Now we have this nice little function that we can call to just die. We can just stop the processing right there. So when we're here, what do we have to do? Well, first of all, this parentheses shouldn't be there. That was bad. That would have been a bug if I didn't catch that. We need to declare some things as local opt-arg. We need opt-ind to also be local. That's another variable that's used internally by GetOps, and we'll use opt here. We deleted where batch size was created there, so we have batch size here. Let's go ahead and default batch size to, I don't know, what should the default batch size be? 1? Yeah, let's go ahead and put it back. Default batch size is 1, but if we get down here, then we can override it by whatever the user gives us. Now, if they give us something that's not a number, we're not going to catch that. Hey, that's your fault if you give us something that's not a number. Where do we use this variable here? Oh, we just use it down here. That's fine. Okay, so let's go ahead and test this now. If we run this, it should do it in a batch size of 1. Awesome, sweet. If we give it -b5, it should go 5 times faster. Hey, that's awesome. What if we want to do it in batches of 50? That's really fast. How about a batch of 9,000? That's instant. That's awesome. Cool. That's really cool. A batch of -5? Oh, we got a problem. That's fine. I don't expect to catch that problem. That's if you give us something that's not a number or a negative number, I'm not going to worry about the error checking here. Error. Yeah, that's going to break. Oh, actually, now I think about it, I think that'll just be a 0. Oh, that's fun. I'm not going to worry about the error stuff. We're just going to talk about, we're going to assume the user gives us valid input, and error checking here will be an exercise left to the reader or watcher. Also, I mentioned if you give it a bad option, let's go ahead and give it -h, which we don't support. You can see that GetOps will print this, and then we fatal out here because it called our fatal function, meaning we return with a non-zero exit code. So, hey, that's pretty cool. We can worry about a help message later. All right, so how are we going to pretty this thing up? Let's go ahead and run it with just a simple batch size of 1. As you can see, it's nice, but there were a couple suggestions people had. The first thing people wanted to see was they wanted to see progress of the files, meaning if I had a function like, where did I have it? Process files, I think was the name of the function. Yeah. So here's where we process a batch of files. Let's go ahead and do something with that. Let's say echo processing batch. So we'll just print processing batch. Actually, you know what? Let's do the len here. Processing batch of the length of how many files we got. So if we put a pound sign here, this will make it the length. So processing batch of number files. Cool. Let's go ahead and run that, and let's see what we get now. You ready for this? That sucks. That's not great. We would ideally like to see the processing batch of however many files we had and the progress bar without them fighting each other. So for now, I'm going to comment this out, but that would be ideal. We would like to get a status report, but also see the progress bar. So a bunch of people had different suggestions for this. So like, hey, can you tack the progress bar to the top? Can you tack the progress bar to the bottom? Here's what I've decided for this video. We are going to make it so this progress bar will always be at the bottom of the terminal. We'll still get messages in the main part of the terminal, but the bottom will just be the progress bar, and we will go from there. So how do we do that? Because that's a really tough thing. It sounds simple, right? I'll go ahead and just put the progress bar at the bottom. It's like, well, what's the bottom? We now, as a programmer, have to be aware of the size of the terminal. I showed you guys before, we have echo columns. We have 87 columns on this terminal. That means 87 columns. I can fit 87 characters before we word wrap. And we also have 32 lines. That means there are 32 rows or lines that we can have. So if we want to put a progress bar on the bottom, we need to know this number 32. We need to put the progress bar on line 32, and we need to put the data that's going to be flowing on line 0 to 31, or I think 0 to 30. We might have it off by 1 error. That'll be fun when we encounter it later. Well, I'll deal with that later. Either way, I think you get what I'm saying. If we're going to put a progress bar at the bottom, we need to know how big the terminal is so we can determine what the bottom is. So that's going to be a lot of fun. If you've ever done graphics programming in the past where you've made like a TUI, a terminal user interface, you know, if you've ran HTOP or something, here's an example of a TUI. As you can see, this bottom area is scrollable. The processors I have up at the top, it's kind of ridiculous the way it's laid out here. So this is a terminal user interface. It's a user interface that's in the terminal. This is one way to do it, but this is a little bit overkill. You might need some sort of like ANSI library, or ncurses is common for this. So a TUI will work, but it's a little bit overkill. We can get around this by doing something that's like half TUI, half not TUI. I'll show you what I mean. So the first example I thought of when I looked at this was cargo. Was it cargo build or cargo install? One of them had a progress bar I thought of. Someone else in the comments mentioned apt. So if you're on like Ubuntu or Debian, you've apt, apt-get, whatever, that has a progress bar at the bottom. So I'm gonna show you guys something cool. I can log into a machine to show you what that looks like. Here's the fun part. I don't have an Ubuntu machine. I run Void Linux on my Linux instances, and they're virtualized. So we're going to have to do this over Docker, and I'm just going to show you how ridiculous that's going to get, okay? So I'm going to log into my server, which is downstairs right now, called Datadyne. This is running Illumos. This is the hypervisor. This is the global zone. So if I do Z admin, here's a list of all my zones that are running. You could think of them like virtual machines. Some of them are hardware virtualized. Some of them are just software containers. You could think of them that way. In here, I have Void, which is the machine I've logged into before. It's running Beehive. So there is a zone running on Illumos, which is running a Beehive instance, which is a kernel virtualized, like hardware virtualization of Void Linux. And then when I log into that, we're now going to use Docker to run Ubuntu. So it's virtual machines all the way down, but it works. So let's go ahead and do that. I have to remember off the top of my head how to do this. Docker run -it Ubuntu bash. Nailed it. I'm awesome. It's been a while since I've done that. So we'll run app update just to make sure like everything's up to date. And then we can actually install some software. So you ready for this? Apt get install, I don't know, Vim. And okay, so I split the difference and got it wrong. You either want apt get here or you want apt install. I somehow opted for the one that was just completely wrong. I don't use Ubuntu that often, so that's what you're seeing here. Let's go ahead and apt install Vim, and we're gonna see what people were talking about. So we're running through the install process. It's gonna ask us yes or no. We're gonna hit yes and watch what's gonna happen. Watch closely. Look at that. Progress at the bottom, but scrolling output at the top, okay? That is what we want. That is what we are going to mirror. That's what we're gonna get. Sure, we're in Africa. Yep, that sounds good to me. And hey, that's awesome. Now that progress bar is gone and that line is completely cleared. Even though we should be at the bottom of the terminal, notice that we're 2 lines above the bottom of the terminal. That might come in, that might be important later. We'll see about that. So let's back out of this. Let's back out of this. And we are back on my local machine on my Mac. So how are we gonna do what apt did? Because a lot happened there. We had a progress bar at the bottom. The progress bar went the whole length of the terminal. We know we can get the length of the terminal with columns. Let's worry about that later. We need to get to the bottom of the terminal so we can update the progress bar and then jump back to wherever we were to start outputting data again. Because remember, we could have data outputting towards the top of the terminal. We could have data outputting right towards the bottom of the terminal, but not quite the bottom because the bottom is going to be reserved for the scroll bar. So we're going to need to be able to save the cursor's position. We're going to be able to bump or jump to random areas of the terminal. We're going to need to be able to clear parts of the terminal. We're going to need ANSI escape codes to do this. So if you've never seen these before, they're a little bit gnarly. You can use the tput command. We're not going to use this for the script, but we can use this just to illustrate the concept here. We could tput setaf1. And this echoes color. So color is a form of ANSI escape sequence. There are also ANSI escape sequences to clear the screen. Because clear, all it did was send something to my terminal. It sent this data to my terminal, and my terminal was able to read that data and do something about it. There's a lot of stuff going on here. We have 3J, we have H, we have 2J. Long story short, this just made it clear the screen. But we can do this with tput setaf1. If we pipe this to xxd, we can see that it passed 1B, which is the escape sequence, open square bracket 31M. We can do this ourselves. We can printf and hex 1B, that was the one escape sequence there, open square bracket 31M, and then we can say, hello world. Let's put a new line here, and there we go. We can mimic that, and we can get ANSI escape sequences in bash without having to use any external commands. So we're going to use this. If you notice 1B is the escape sequence, that's in hex. We can just change this to E in bash. This will be recognized as the escape sequence. So we're going to use this going forward. And real quick, if you are following along at home, things are about to get a little bit gnarly here. And if you get yourself into trouble, if you've ever like exited out of a command and somehow your terminal's all messed up and you can't see what's going on, maybe you're like hitting keys and nothing showing up. Let's do a STTY minus echo. Yeah. I'm typing on the keyboard, nothing's showing up. I can run commands, but you can't see them show up. That's not great. I'm not going to remember how to fix that. Type in reset, reset, and it will reset the whole terminal. You couldn't see that because I turned off that. That's what I'm typing in, reset. It won't reset your computer, it'll reset your terminal. If you're scared of that, tput reset will also do something similar. So if you get yourself into a weird situation, Control-C a bunch, reset, hit enter, and if all else fails, close your terminal and open a new one. So yeah, disclaimer over, let's jump into it. So in order to actually make something happen here, before we display the progress bar, we need to do some work. We're going to have to move to the bottom of the screen. We're going to have to draw our progress bar there. We're going to have to move back up so we can draw data. It's all a little bit confusing. Before we even do that, we need to know where we're drawing data. So we need a couple new functions here. You ready for this? Let's create init term. This will initialize our terminal for drawing, and then deinit term. So we're going to be doing some things to the terminal, like setting different modes and stuff, where if this program exits, either it is crashed or someone kills it, or it exits on its own cleanly, we're going to need to clean up some of the work we've done. And I'll show you what that looks like. Basically, for everything we do to initialize the terminal, we'll probably have to undo it in our deinit there. But for now, we'll keep these as just empty functions that we can kind of stub in here and then fill out later. So we take our options here. We're all ready to go. We're ready to find files, blah, 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 blah. Once we've taken our options, we can go ahead and we can init term. Again, these don't do anything yet. And then we need to call deinit term when the program is over. Either it was, killed or we exited successfully. The way we can do that is by trapping a signal. Trap the name of the code we want to run. So this could just be code or this could be a function. So we want to run deinit term on exit. So what this says is when the script exits, we are going to deinit term. In fact, you know what? Actually, let's do these in this order. This feels safer to me, because if init term were to crash halfway through, or I would rather clean up first and then basically if we do it in this order, there's no race condition, or if there is a race condition, we've severely lowered it. All right, so what we're going to do here is I'm going to write out what we need to do, and then we're going to go back and actually implement it. But we need a plan of attack here. So we need the bottom line of the terminal to be our progress bar, meaning we need that bottom of the terminal to be blank. We need nothing to be there. Because if we're up here, we can jump to the bottom and draw the progress bar. But if someone's ran a bunch of commands or whatever, and their prompt is all the way down here, we need this area. We need this area to put a progress bar. I don't want to delete anything they have. So the easiest way for us to do that is by omitting a single new line. If we omit a new line from our program, again, I got a new prompt because I'm not in here. If we omit a new line, this will show up at the bottom, and then we know for a fact we have a blank space at the bottom. If we're somewhere up here, doesn't matter, that new line's harmless. But if we're all the way at the bottom, that new line will ensure that we have room to draw our scroll bar. So the first thing we want to do here is ensure we have space for the scroll bar. And like I said, we're just going to omit a new line, so printf new line. That's it. You could also put echo here, whatever. I'm just going to use printf because I'm going to be using it more later, but we print our new line there. That's the first thing we do, is we make sure we have room for it. The next step is we don't know where the user's cursor is, so let's save the cursor location. We have no idea where their cursor is, where anything is, what line they're on when they press enter to run our program. So save where it is, because that way we can do work and then revert back to where the cursor was, and it's like magic. So once we have that location saved, the next thing we need to do is set the scrollable region margin. So here's a cool thing that can happen. Here's a magical little thing you can do in your terminal. You can create scroll regions using ANSI escape codes. This is something really magical. I can say that I want this region, I want lines 5 through 8, these are random numbers, I don't know if I'm highlighting 5 through 8, to be scrollable, and then the text will only scroll in that area. This is super useful because the default scrollable region is from 0 all the way to the bottom of your terminal. Imagine if we just moved it 1 up. Now the data will scroll in that region, but the bottom will remain untouched. This happens if you're using something like Tmux or any sort of program like Vim that has something at the bottom. The scrollable area, like if I'm inside Vim, look at this. We have this down at the bottom, we have this down at the bottom, but everything else scrolls around it. That's kind of what we're doing here in the terminal. So we can actually set the scrollable region. I'll show you how to do that, but for now, let's just stub it out. So we have set the scrollable region. Now we just need to undo what we did. I know it sounds super simple, but yeah, we saved the cursor location. So let's restore the cursor location. So we were in this save state. We did some work. Now we're going to revert back. And the last thing we need to do is we need to undo that new line that we did. Remember how we threw a new line in there in case you may have needed it? We need to undo it by moving the cursor up 1 position. So move cursor up. This will just move it back up so it'll cancel out this new line that we put in there. Okay, so the fun part. How do we do this? Well, we're going to need a guide for ANSI escape sequences, and I'll show you where to find them in your browser. So let's pull that up right here. Oh my God, what's that? Is that my YouTube channel? Is that my current live feed of subscribers? At the time of recording, do I have 41,542 subscribers on YouTube? Yes, I do. Thank you so much for subscribing, everyone. I appreciate it so much. If you're watching this video and you like what you see, go ahead and hit that subscribe button. I like watching this number go up. When I hit 100,000, I'm going to be so annoying online because I really want to get one of those plaques and be like, yeah, what's up? So I like seeing this number go up. Go ahead and hit subscribe if you're watching. Appreciate it. Thank you. Sponsored content over. Here we go. There are a couple cheat sheets out there for ANSI escape sequences. I really like this gist. Like, I know this is not official documentation. Here is just a gist of different ANSI escape sequences. I'll link it in the description. I love this. This has everything we could possibly need. So it has all sorts of things here, like move cursor to the home position. You can just do escape, open bracket, H. So escape, remember, is the \E for us. If we just omit open bracket and then H, we will move the cursor to the home position of 0, 0. Let me show you. So let's go ahead and save this. Let's go ahead and printf the escape sequence, and then it's open bracket H. That's it, right? Cursor's back up there. Look at that. Bam. So kind of weird. You may have ended up in the situation before and you're like, oh God, my cursor's not where I expect it to be. Reset. Just reset. You'll be fine. But yeah, there's all sorts of other things you can do. We can move the cursor to line number that, column number that, move cursor up number of lines, move cursor down, blah, 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 save cursor position, restore cursor position. So yeah, as you can see, the stuff we need is going to be here. There's a ton of fun stuff here. Erase in the display, erase from cursor until end of screen, erase from cursor to beginning of screen, clear the entire screen, erase the entire line, erase from, like, there's all sorts of things you can do. I would recommend taking some time and look at this. Like, there's so many things, bold, colors, all that stuff you expect will be here in this little gist. I love it. It's so fun. You can do some really cool stuff with this. So let's grab what we need. So pull back open our code, and we can see that we need to save the cursor location. So we need to print something to the screen to save the cursor location. We need to printf something to set the scrollable region. We need to restore the cursor location, and we need to move the cursor up. Well, we can start consulting with the gist over here and see what we need. So first thing we have to do is save the cursor location, save the cursor position, escape 7, and then restore is escape 8. So let's go ahead and implement that. So save the cursor location, escape 7. That's it. Truly, like, that's it. That's all you need. Restore the cursor position, escape 8. Hey, that's awesome. Move the cursor up. I think that was on the list, right? Move the cursor up number of lines, so we can do escape $A, and it will just move the cursor up 1. So $, is the number we want to move it up. So 1A, escape open bracket 1A. Escape open bracket 1A. And I put it in the wrong spot. I had the cursor in the right spot. Escape open bracket 1A. Oof, there we go. The last thing we need is we need to set the scrollable region or the margin. So let's go ahead and figure out how to do that. Okay, so this is really funny. I realized on the gist that I was using that they didn't actually have anything for scrollable region or margins. So I, for some reason, thought it was there. I guess I just had it in my head. So that's wild. I found nice documentation from Ghosty or GhostTTY, which, if this isn't a sign that I need to try out this terminal, I don't know what else is. But this is what we were looking for. Set top and bottom margins. So you send the escape sequence, open square bracket, a number, semicolon, number, and then the letter R. So the number is top and bottom, basically. So where the top of the scrollable region is and where the bottom is. So what we want is 0 for the top. We want to start all the way at the top of the terminal. And then the number of lines -1. We want to be able to scroll everything but the bottom number. So we'll go ahead and implement this now. So we want an escape sequence here. We want to open a square bracket. We want a number, semicolon, a number, and then, what was it? R, I think it was. Yes, just the letter R. So now we have to give it 2 arguments, 2 different numbers. So the first is the top. That's where the first part of it's going to be. That's going to be 0. Just hard-coded to 0, really simple. The bottom will be the number of lines we have -1. Now, let's talk about this variable, because we can't just introduce this brand new amazing variable. We used it here. We had lines. That's how many lines we had in the terminal. The reason this works is this option is turned on by default. It's called, was it check win size, I think? Yeah, so check win size. As you can see, this option is turned on. It's a shell option, and this will give us access to the lines and columns variable. Things can get a little bit weird with it, but for the most part, it seems to work. So we'll talk about this in a second, but basically right now we're going to use this variable lines. Let's go ahead and just make sure it's also turned on in our main function, check win size. That way we'll have access to it. Like I said, it should be on by default, but it's always good practice just to turn it on if we're going to be using it. Let's dive into the win size thing, because things can get a little bit gnarly when you're dealing with this. Notice how much more complicated this script already is than the previous one. That's why I kept the previous one so simple. If we don't have to deal with ANSI scapegoats, the most complicated thing we have is a carriage return character. It's simple. It's easy. This one, I'm sorry, you're going to have to follow me a little bit here. Let's go ahead and make a new script, a new program called win size. So user bin env bash, the first thing we want to do is turn on check win size. Let's go ahead and save that. Chmod, if I could type, +x win size. Let's go ahead and run that. It should just work. It shouldn't print anything. Awesome. Now that we're down here, we can echo lines equal lines, columns equal columns. Hey, so we turned on check win size, and now we're going to print those two variables, right? We have a problem here. They're not set. Why are they not set? Get ready for this. This thing is super weird. Let's open up the bash man page. Check win size. Let's go down here and let's see. So lines used by the select command, blah, blah, blah. Automatically set if the check win size option is enabled or in an interactive shell upon receipt of a sig winch. That's spoiling. That's some subtle foreshadowing for later. If set, bash checks the window size after each external non-built-in command, and if necessary, updates the values of lines and columns using the file descriptor associated with standard error if it is a terminal. Notice this, after each external non-built-in command. So why is it like that? I have no idea. Turning it on isn't enough here. We need to call an external command. So we could just call bin true, which is an external command, and, well, actually that one's not set. Wow, okay. It's not set, but it still set the variables. That's really funny. Sorry, I keep saying not set. Bin true doesn't exist, but it still set the variables. That's so funny. What is it? User bin true, probably? There we go. Hey, that looks good. Now those are set. What about if we use a bash built in, like true? True is built into the shell. Doesn't count. It's not external. What if we pipe true to true and we create a subshell? Then it's set. Awesome. What if we create a subshell manually like this? Then it's set. I don't quite know why it's like that. I think it's super strange. I wish just turning on the option would cause it to update those variables, but it doesn't. So if we're going to use check win size, we're going to have to do something like this. Colon is just a command on bash that does nothing by default. So we could do that. And if we're going to do something like that, we should probably say something like this line is to ensure lines and columns are set. So not great, weird. Don't love that we have to do it that way, but that's how we can guarantee those variables are going to be set. So let's go ahead and vim both these scripts now. Let's take this logic, because that's what caused those to be set, and let's put them right here. That way, when we get down here, we know columns and lines are going to be set. So super weird. Wish it wasn't that way, but that's how it is. All right, so let's take some inventory here. We have our init term function here. We have our deinit term function, but it doesn't do anything. And then we call it here. That all looks well and good. So if we run this, what'll happen here is it should make the bottom of the terminal inaccessible, because it should take it out of the scrollable region, scrollable margin. But everything else should look exactly the same. And in fact, if we run it, we won't see any differences. It's only when I scroll to the bottom that we should notice that it's not there. And then we can, of course, type reset to fix everything. So if we scroll to the bottom, we'll notice that we do get there. Okay, so what did I do wrong? Let's take a look at this. I see what I did wrong. Do you guys see what I did wrong? Take a look at this. We turn on check win size after we initialize the terminal? Yeah, I don't think so. Let's go ahead and move these around. All right, we'll turn on check win size. We'll run this so we have lines and columns, and then this can run. So let's go ahead and rerun that. Cool. So this is running. This is awesome. Now if we scroll to the bottom, what's going to happen? Look at that. Look at this. We have a reserved line. I can't get there. I can't get to the bottom line, no matter how hard I try. So tput reset. Let's get ourselves out of that situation. But look at that. Our initialized terminal seems to be working, or at least it can set a scrollable margin, which, hey, that's pretty awesome. Let's go ahead and implement the deinitialization now. We have init term. Let's go ahead and do the opposite to deinit it. So to fix it, the first thing we want to do is like we did above. It's going to be a little bit different than what we did above, but still similar. Save the cursor location. We don't know where the cursor currently is. We don't know where they are, but we want to save it so we can revert back to it. Because all we need to do is jump to the bottom and fix some things, all right? So now that we have the cursor location, let's go ahead and reset the scrollable region, also called margin. Let's move cursor to the bottom line. So it doesn't matter where we are currently, we're going to jump to the bottom line for the express purpose of clear that line. So move to the bottom, clear it, get rid of any progress bar that was there. We will have an empty line then, and let's reset the cursor location. So at the end of the script, just like the apt command, the bottom bar will be empty and we won't have to worry about it. The progress bar will be completely gone. That's what we need to do. So save the cursor location. Hey, look at that. We already know how to do that. We do that above. Printf, the escape sequence, and 7. Cool. Now we've saved the cursor location. That means we also know how to reset the cursor location. Printf, escape sequence 8, and hey, look at that. We reset the cursor location. We need to reset the scrollable region. Remember how we set it above? We can do the same thing here. %d, %d, r, and we can give it 0, and then we can just give it the full canvas. So instead of lines -1, we just give it the full lines, and then we have reset the scrollable region. So now we need to move to the bottom line and we need to clear the whole line. I don't have those memorized on the top of my head, but we can pull them up. They would be on the gist that I pulled up before. So right here on that gist, move cursor to line number, number sign, column number, number sign. So it looks like there's two different formats for this, H and F. Let's just go with H. So escape sequence, open bracket, number, semicolon, number, capital H. So just like we did it with the R, which set the scrollable region, we give it an H instead, and suddenly we're moving the cursor. So let's go ahead and do that. So move the cursor to the bottom. We know we can give it the escape sequence, open square bracket, number, semicolon, number, capital H. Now we have to figure out where do we want to actually move the cursor. Well, this is simple. We want to move it all the way to the bottom line, and then it doesn't matter what row we put it on. It just matters that we move it to the bottom line. Well, I guess technically the bottom row, it doesn't matter which column it is, as long as we get it to the bottom. So we'll just put it right the 0th spot. So in order to do that, we just put lines here and then 0. So a little bit confusing. It's the opposite of what's above, but that's because this is setting the top and bottom. This is saying jump to the bottom line and then go to the 0th position. It doesn't matter what that number is. And finally, all we have to do is clear the line now that we're there. So again, I don't know how to do that, but there was something here. Erase the entire line. Look at that. Hey, that sounds good. What are these other ones? Erase from cursor to end of line? Oh, we could just use that one because we're already at the beginning. So escape, open square bracket, 0K. So let's go ahead and implement that. So printf, escape, open square bracket, 0K. Was it lowercase? Oh, it's uppercase K. There we go. And there we go. Now we have a deinit term function. So can we run this now? What actually happens if we run this? What's going to happen? What do we expect to happen? Here's the thing. Oh, we should run it with a bigger batch size. Let's do a batch size of 5 so it goes by pretty quickly. It'll run and it set the scroll region and then it reset the scroll region. So we should be able to get to the bottom of the terminal. That's awesome, but we can't really tell that it did anything, right? So let's go ahead and run it while we're at the bottom of the terminal. Look at that. It made room for the progress bar. Yes, the progress bar is one above it, but it made room for it. That's what we were trying to get. So that's awesome. It makes room for us at the bottom. And then when we finish, we have that blank space down there, but we should be able to get to the blank space. Awesome. The scrollable region gets reset at the end. Even if we control C it, it should still run through the deinit term function. And here we go. That's awesome. Even though you can't see it, that's a huge amount of progress here. So let's go ahead and let's take a look at what we have and let's figure out how to actually make the progress bar get down there. So, you know, I just realized this. I don't do this personally, but I know some of you out there might like this. If you've ever done like graphics programming or OpenGL stuff, I'm going to do this a little bit. Like I said, I don't typically program like this, but it might be easier for some people to see. This is a way of visualizing what's happening here. So I think this is right. Yeah. So if we look at this, we print the new line, then we save the cursor position. So anything that happens in this level of indentation is while the cursor position is saved. And then we back out of that level of indentation by restoring the cursor. And then we back out by moving the cursor up. So we move the cursor down, we go into a level of indent. All this stuff happens while the cursor is down, and then we move the cursor back up. We save the location here. All this stuff happens with the saved location, and then we restore the cursor location. Like I said, I don't typically do this, but this might be easier for some people to follow along. Same thing here in Deinit. We save the cursor location, so let's go ahead and indent our code a little bit, because all this code happens with the cursor location saved. What do? We reset the scrollable region. We move the cursor to the bottom line while we're in the new scrollable region, then we go ahead and clear it. Actually, probably make more sense for this to be like that. Let me think. There we go. Put these at the same level. So we save the location. While we're in there, we reset the scrollable region, move the cursor to the bottom line, clear the line, and then we reset the cursor location to wherever we were. This might be an easier way of viewing it like this. I'll leave the code like this. Like I said, typically don't do this, but might be easier for some people to follow along to kind of understand what the scope of things are. So let's move up to the progress bar. How do we print the progress bar? We run through all this code right here to set the progress bar, but how do we actually print it? Because right now we just have a string. We have this whole string here, and we print it with a carriage return at the beginning. This worked great when we didn't set the bottom of our terminal to have the progress bar. So what do we have to do? We have to shoot this to the bottom of the terminal somehow. So we're gonna have to put some codes there to get to the bottom of the terminal, print it, and then move back to where we were. So luckily we already know how to do a lot of this stuff. So let's think about this out loud. We should save the cursor location. Done this before, that's simple enough. We should move to the bottom line. So we don't know where we are. We're saving the location. We move to the bottom line. We should clear the whole line. We don't know what was left there, if the progress bar was in some weird state or whatever. Then we should print the progress bar, which we have pretty much right here. And then we should restore the cursor location. So hopefully this makes sense to people what I'm saying. Save the location, move to the bottom line, clear the line, print the progress bar, move back to the original location. And this function is kind of standalone. So that's great. So let's go ahead and implement this. If you remember, we want to printf, we want the escape sequence 7. That way we'll save the cursor location. And then for here, we want to printf and we want to do a / escape 8 to restore the cursor location. That's awesome. Before we continue, let's take this line here, move it up here, and just save this into a variable instead of printing it. So we already have that S variable. We could just do this and overwrite the S variable with what's already in it. Actually, no, let's plus equal this. So the whole thing will be in one big giant variable called S, and we can just print that to the screen. So we can just printf %s for a string, and then whatever's in $s. Hey, simple enough. That's how we print the progress bar. So the last two things we need to do is we need to move to the bottom line, and we need to clear the whole line. We've done something like that similar. We've moved the cursor to the bottom line, and then we've cleared the line. So let's go ahead and just take that code. And let's put it here and get rid of that. Indent this a little bit, and hey, look at this. This might be all we need. Save the cursor location, move the cursor to the bottom, clear the line, print the progress bar, restore the cursor back up. That should be all that's necessary for our progress bar, right? Moment of truth. Let's test it with a batch size of 5. That's pretty cool. That is really cool. So it ran, it put the progress bar at the bottom, and you can see it just kind of gave us room up top, and then it finished. Couple little nitpicks here. It finished with a blank line. Why is there a blank line? Because in our original script, we have an echo all the way at the bottom. That was to put a new line after the last progress bar was ran. We no longer need that because we're jumping around with the cursor manually. We don't need that last echo. So we run this and we get our progress bar at the bottom. If we control C, it hung. I don't know why it hung on that example. That was super weird. I actually have no idea what happened there because I didn't expect that. I expected that to happen. I mean, I just got really unlucky when that signal got sent or didn't get received by the bash script. I don't know. I have no idea what caused that. But let's get to the bottom of the terminal and let's rerun the program all the way at the bottom of the terminal. And it works because we made room for that progress bar. And as you can see, we're one above the bottom now. Hey, that's awesome. So that's really cool. Does that fix our problem? Let's go ahead and uncomment the echoes here. So we have echo processing batch of files. Let's go ahead and run this now. That is pretty cool. That's really cool. It seems like it's working, no problem. Let's make a batch of, I don't know, 100. So this should run, what, 10 times? That looks awesome. That's amazing. In here, we could even go a little bit crazier if we want to do. We could do like a 4 file in files. and we could print the name of the file that we are processing. So we could say echo, we do like a little arrow sign, and then the name of the file that we're processing. And then we can local file so we don't do anything. So we should get little blasts of files that we're processing. Let's process 3 at a time. That's kind of a cool way of seeing it. The beauty of this is that we can actually, it might take time to process each file individually. So this sleep could technically go in here and it would still work. We can output any number of lines because we just have a little scrollable region. Sleeping of 0.01 might be hard to see. Let's go ahead and make this 0.1. This is gonna be really slow, but it'll illustrate the concept. Let's go ahead and do 10 at a time. There we go. So that is pretty cool. We got our progress bar at the bottom. We have our batches being processed at the top, and we're getting output. We're getting feedback as we go along and run this. That's awesome. This is really cool. It seems to work no problem. So what is left to do? Well, what I think is this bottom line. Look at this. Oh, I tried to touch it and then it stopped scrolling. Look at this. How far out does it go? I don't know, roughly 50 characters. Shouldn't it go the whole length of the terminal? Let's make it do that. That could be kind of cool. So how do we do that? We have to go up to our progress bar function and see how we have a length set to 50 here. You might think, let's just set this to columns, right? The problem is the length of it also includes some extra characters. So we put this whole suffix here that counts as characters. We put an open and closed square bracket around the progress bar that count as characters. So we're gonna have to do things in a slightly different order to get the effect that we want. So let's start rearranging some stuff to make room for things. We have our bar char, we have our empty char, we have our percent done. We have enough information to calculate that right away. That's awesome. Our length and the number of bars we need, we don't quite have enough information yet. We need to know how long the progress bar should be. We need to know how much space we have minus all the characters we're going to draw. So we need to know the suffix. And in this example, the suffix would be the, here, I'll show you. In the progress bar here, the suffix would be the part that says 11 out of 100, 2%, 3%. As you can see, it's already a little bit broken now. So we need to make the suffix up here and then figure out how much space it took up. So we have our suffix here, and then we have, where do we do it? Right down here. So let's take this and let's just set that to suffix. There we go. In fact, we can combine these two lines into this. Awesome. Suffix equal. Notice there is a space character there. So now we know the length of that. So in order to get the length of the progress bar, we need arithmetic expression around this. We need the number of columns, that's the total, minus the length of the suffix. This is how many characters we have to reserve to print the suffix, minus 2. Now, why do we need minus 2? That's because there's an open square bracket here and a closed square bracket here. That's 2 characters. We need to make room for them. So let's do a minus 2 there, and we should be good to go. So if we did everything right, we have our bar here, and then we do that. So we should just add the suffix to this S variable, and that should be good to go. Let's go ahead and run this and see what happens now. Hey, look at that. It takes up the full length of the terminal. How cool is that? Let's go ahead and speed it up a little bit. Let's get those sleeps out of the individual files like I did and put it in the batch. That way the batch speed will be determined by how many files there are. So let's go ahead and do that. And we can see the progress bar is growing. Hey, that's awesome. What if we shrink the terminal a little bit? Hey, look, the progress bar does that. How awesome is that? What if we make the terminal really large? Well, it's going to go underneath my camera, but as you can see, it still works. How awesome is that? That's really cool. So what about in this situation? So what about if we resize it? What's going to happen then? Let's go ahead and run this and let's resize it. That doesn't look right. That kind of looks bad. Well, remember I talked about some subtle foreshadowing earlier? I mentioned sig winch, the winch signal. This is sent, here it is. This is sent when your terminal is resized, which is super useful. So in our script, we can get a signal that our terminal's been resized. If that happens, we just need to reinitialize the terminal. So we have this init term function that does all its works. Look, it makes sure we have the scroll bar there. It saves the cursor location. It figures out the scrollable region. It restores the cursor location. It does all this stuff for us. So that way, when we init term here, all we have to do is trap init term to winch. The name of the signal is winch, sig winch. So if we do that, one line of code added should make it so we can respond responsively to size updates. So let's go ahead and run this. Let's shrink the terminal a little bit. Hey, shrink a little bit. Hey, look at that. Grow it. That's amazing. That's incredible. Is there one little last thing? Kinda, but I don't know if we're gonna solve it here. Let's go ahead and make it really, really, really small. I mean, it works, but it's kind of condensed, right? Is that something we need to care about? Here's the thing. I went over to apt. I did the same thing, and we kind of get the same output with apt. So I think for all intents and purposes, we're going to call this okay. I would say this is fine. We get the progress bar at the bottom. We get arbitrarily large scrolling output at the top like this, and we can handle dynamic resizing of the terminal. So there's still a couple more things to do, but this goes to show how much work goes into doing that. Remember my first video where I made a little progress bar to the screen and everyone's like, oh, wouldn't it be nice if the progress bar was at the bottom? Oh, yeah, it would be nice. Look how much work it takes to get there. It's fun. I like doing this work. I think it's a ton of fun, but I hope you can appreciate how much work it takes to get to the bottom of the screen and draw a progress bar and go back to the top of the screen and keep doing your work and make sure you clean up after yourself, after your process exit. There's a lot of stuff that goes into it. A lot of care has to be taken. So I think the final thing we want to do to clean up here is we already have some good stuff. Let's go ahead and let's just say our bar char is a pipe and our empty char is a space. That way we can just use them because they're global variables. So we have bar char, which is now becomes bar char, and we have empty char, which is just capitalize all that. There we go. So we have bar char, we have empty char. The reason I'm making these global variables is because we can make them options. So we can say any sort of option we want. What will we name these? So we'll call it C for char and E for empty. Not great names, not great options, but you know, this is just to show that we can modify this at runtime as opposed to having to edit the script. So if we're here, then our bar char will be set equal to opt-arg, and we hope the user gives us one character. If they give us multiple characters, things are going to break. Our math isn't going to quite work, but that's okay. Empty char equals opt-arg. Now that we have this here, we can go ahead and rerun our script, and it should look exactly the same. If we rerun it with a char of a pound sign and an empty char of a dot, then the progress bar is pound signs and a dot. Hey, how cool is that? That's so awesome. You could change those characters to be whatever you want. Like I said, if you do something like this, like, you're on your own, man. I don't know what to tell you. Looks kind of cool, but not great. So yeah, there you go. There's a progress bar that updates based on the size of the terminal, based on how many are running a batch, and it will show up consistently while the output still flows in there and handles all the cases like starting at the bottom of the terminal, starting at the top of the terminal. If you want anything fancier than this, you're going to have to get into full-blown TUI status, terminal user interface. I'm not against doing that, but I'm just letting you know that would be the next logical step. There may be some other things you can do, but if you want to get way fancier, you want the progress bar to be consistent at the top or on the right side of the terminal, you're looking into TUI. You're going to have to look into ncurses or libraries like that, or get very fancy with your ANSI escape sequences. You're going to have to start learning about the alternate buffer. I've done code like this in the past, so we might actually be able to do it here on the terminal. Let's go ahead and see. If I curl this, does this work, or is the terminal too small? The terminal's too small. I'm going to fire up a small terminal for you. Curl nightfall.ysap.sh, and you get a bash script, pipe it to bash, and oh my god, is it still too small? Oh my god, it's still too small? Oh wow, okay, let's go ahead and make this bigger. All right, so I'm making my terminal giant, and there we go. There's a media player that I wrote in Bash. It goes to the alternate buffer. It can play music. It streams it from my server. Hey, that's pretty cool. If you're interested in that, I have a video on that. I'll link that, of course, here. You can go check that out. This goes into the details of what it would take to actually write a TUI in Bash. So if that's what you're interested in, I would say go check that out. And yeah, if you made it this far, then you are a super nerd certified. Thank you so much for watching. Yo, I appreciate it. Go check out that TUI video. I'll make this code available online. I'll link it in the description. Go ahead and hit that subscribe button. Share this video with your friends. Let's get that subscriber number up. I want to see how many I can get. My goal is I would love to hit 50,000 by the end of the year. And I think I'm on track to do that. So that'd be awesome. Of course, stretch goal, 100,000 subscribers. So that'd be amazing. Go ahead and hit that button. That's awesome. I also have a Patreon. Go check it out if you want to. But yeah, I don't even need to advertise that in every video. Go subscribe. Let's get that number up right now. So yeah, appreciate it.